IPv6. Relatively far away. IPv4 is what we will talk about today. Next. Look down. There's something called a subnet mask here. That's the core of what we're talking about today, including a default gateway behind. In the future, when we talk about data communication across network segments, we will talk about the concept of gateway. Today we mainly talk about IPv4 and subnet masks. Some connections between them. For example, I will write you an address. 192.168.1.111. I also write the mask on it. 255.255.255.0. Let's not focus on its specific use. Remember these numbers first. I don't know if you have any knowledge about the encoding format of the computer before. Computers only understand binary when reading data. For computer, it can only recognize binary. That is, it only recognizes 010101. For example 192.168.1.1. It doesn't know these points. Then, for binary. In fact, it is convenient for the computer to process. Some students may ask, how did the 0101 pass? Since the computer can only recognize 0101. After that signal is transmitted on the current physical link. How did it become 0101? This is what each device's network card does. Such as electrical signals. We use high and low frequencies to represent 0101. Then it is converted by the network card. Finally converted to binary. Then let the device handle it. But everyone think about a question. Since it can only recognize binary, why do we now see IP addresses in this format? Because binary is not very easy for us to deal with. When we configure in the future, an IP address is a 32-bit binary number. You go to assign an IP to an interface later. Do you have to knock 0101 32 times? It's too much trouble. So, because we humans are not easy to deal with, so a decimal system was developed. So my set of numbers above. It's called decimal. Decimal means every decimal. Maybe because we grew up. I've been learning decimal. So everyone has become accustomed to decimal. That's easy to understand for binary. It is every 2 into 1. You will see that binary has only 0 and 1. Only 0 to 9 in decimal. That is, there are no 10 in decimal. Hexadecimal is no hexadecimal. There are no 2 in binary. So we will also talk about base conversion today. First of all, you need to know the 32-bit binary number is a format of an IP address. We can write it as 4 sets of decimal numbers. The largest single digit in a decimal number is 9. Everyone can see a total of 4 groups. 192, 168, 1 and 111. A total of 4 groups, separated by 3 dots. We refer to this format as dotted decimal. This is the composition of dotted decimal. So you will find formed so far. Conversion between binary and decimal. That is 32-bit binary number. It can be written as 4 sets of decimal numbers. This is a core transformation of it. For the number of digits, the value expressed by each number in each bit is different. Back to front. The later the number represents, the smaller the value. Everyone starts from the basics. For example, I write a 101. We calculate in decimal. It's called a bit. This is called 10. This is called the 100. Then everyone will find, in this bit, the 1 represents the 1. This 0 represents 0 times 10. And the 1 in this bit is 1 times 100. If it is 201. Here are two 100. Everyone will find each digit if it is in a different number of digits. In fact, the values it represents are not the same. Followed by a small value. Large value in front. If a digit has no way to represent the current value. For example, now want to represent a 10 in decimal. But a single digit can only represent a maximum of 9. That now wants to mean that 10 can only go forward by 1. This one becomes 0. 1 step forward. 1 to represent 10. It's called decimal. That binary is the same thing. One bit of binary represents at most 1 0 or 1. How to express a 2 in binary? There is only one 1 in the single digit. If you want to express 2, you can only move forward by 1. Turn this bit into 0. Which one is taken as 1? It's called carry. These are what we call bases. The following are the rules of the base. Binary 0 and 1 in different bits. The meaning is also different. No matter which base. If a bit represents a value of 0. In fact, this 0 means that it will never take a value. Then if it is 1, it represents the value. Because it has only 2 variations per bit. 1 means that this person has. 0 means that this bit does not. And the information we express should correspond to different digits. To correspond to a different number of digits. For example, I want to express a 1 in binary. In fact, the decimal represents a 1. Now here comes the problem. What if I want to express a 2 in binary? Okay. 10. 'Cause I'm going 1 step forward. 10 is 2 in our decimal system. If a 3 is expressed in binary, the last bit is 0 plus 1. So it's 11. In decimal it represents 3. Because it's too slow to write them down one by one. So I just wrote it in multiples of 2. If a 4 is expressed in binary, because 11 represents a 3. So further forward you want to say 4 is 100. Now the difficulty level up. What if I now want to express an 8 in binary? Let's take a look. The last digit is 1. Represents that the value of this bit is 1. This 10 corresponds to. My bit value is 1. Stands for 2. So actually if there are 3 ones here, it stands for 7. If I want to express 8, I have to move forward 1 bit. It's 1000. Everyone will find. When we finish writing these now. In fact, we should write it more disciplined like this. That is, align the last bit. It will look more beautiful. You will also find that there is a rule in it. When the last bit is 1. Actually it stands for 1. When the second to last digit is 1. It stands for 2. When the third to last digit is 1. It represents 4. When the fourth to last digit is 1. It represents 8. So it stands to reason that if all 4 bits take the value of 1, then add the previous values, is equal to 15. So if I now want to express a 16, just add 1 to the original. We will find 1 plus 1. 1 plus 1. Then carry over. Recarry. Then it becomes 1 and 4 0s. Represents a 16. In fact, this is a conversion between the bases. 4 digits can only represent a maximum of 15. Then if I want to express 16, I can only go 1 step further. Now the 4 ones actually represent